Okay, 11.2 is on combinations. Combinations are a lot like permutations, except they have one difference. In permutation, you're arranging things so the order mattered. In combinations, doesn't matter what combination you put something in. It just matters how many different combinations you can end up with. So we're going to run through a few examples here just to get us set up to the combination formula that you can use. So it says, suppose a local TV network needs to choose 3 people from 8 candidates to judge amateur singing on a new reality TV show. In how many ways can they be chosen? So I've got 8 different people, and we need to choose 3 of them. So that means that let's say for this example, I chose the black, the blue, and the green. Okay, so I've chosen 3 out of those. That leaves me 5 that I'm not choosing from. But they're part of the combination to figure out how many I need, or how many different ways I can choose these people. So that means I would have a total of 8 factorial ways of choosing them, if I was choosing all of them. But 3 of them are what I want. So there are 3 ways that I can choose those people. So I could have chose black, blue, green, green, blue, black, black, green, blue. Okay, 3 different ways of ordering how I could have chose those. And that means that left me with 5 other people that I didn't choose, and I could have had those 5 people in whatever order that I chose them. So there's 5 factorial ways. So this is my number of chosen, and this is number not chosen, and this is the total. Whoops, I was going to make a number sign there. This is the total that I had to choose from. Okay, so just like in permutations, you got to take those repeats out of there. So that's why it's divided by that 3 factorial divided by 5 factorial. So if you do this in your calculator, you end up with, oops, not, oh wow, 56 combinations that you could have had from those 8. Because I'm just saying right now that I chose those 5, or those 3 black, blue, green. That was one example, and I could have arranged them in whatever order. But then I also could have went with blue, red, green, or I could have went with the, I guess that's kind of a beige, pink, purple. So that's where my example, I chose those 3 colors, but I could have chosen any of the 3 colors, arranged them in 3 different ways. So that means that I had 5 that I didn't. Next example says, we can look at this problem another way. Suppose we want to arrange 3 people. Anytime you see the word arrange, that means that you're going to be doing a permutation. Remember, how you permute means how you arrange. So suppose we want to arrange 3 people from these 8. This is another problem that we have solved before. So in permutation, the order that they're in matters. So that means that if I chose the blue, then I've only got so many choices for the next one. If I had chosen the red, then the red is out and I can't choose that one again. So this is an arrangement. That would mean that I have 8 P3 ways to choose it. I have 8 total. I'm arranging them 3 at a time. So that gives me my 8 permute 3. So using the formula, that's 8 factorial over 8 minus 3 factorial. So that equals 8 factorial over 5 factorial, which is 336. Remember, you can also do this on your calculator using that math button and then going to the NPR formula. So I've got 336 possible ways that I could take 3 people from those 8 people and arrange them. Okay? So because order is mattering in an arrangement, And I'm going to write this here because it'll help to explain the next part. So because order matters in an arrangement, each selection for this example is ordered in 3 factorial ways. Okay? So I could have chosen this, we'll call this one mauve, yellow, purple. I could have went yellow, mauve, purple. I could have went yellow, mauve, yellow, purple, mauve, and so on. So I can pick my 3 colors, and then I can arrange them in 3 factorial ways. But selecting or choosing has no concept of order. So if you think about if you go to Manchu Walk in the city, you get, when you make your combination, you can choose 3 things. They don't care if you choose the honey garlic chicken and the stir fry vegetables and fried rice, let's say. So you chose those 3 things. They don't care what order you chose them in. You just have to choose 3 things. You have a lot of different combinations of those 3 things that you can do, but the order doesn't matter. So if I look at this, I had 1, 2, 3, 4, 5, 6. I have 6 permutations, so 6 ways I could arrange those 3 colors, but in a combination, it doesn't matter. So all 6 of these permutations would be considered one combination. Okay? I'm choosing 3 things. I don't care. It's a combination, so I don't care how I arrange them. So every time I choose 3 colors, there's going to be 6 ways I can arrange them, but those 6 ways don't count as 6 combinations because it's still going to give you fried rice, stir fry, and honey garlic chicken, right? So because selecting has no concept of order, all 6 permutations would be considered identical, or one choice. One choice or one combination. So then to calculate how many ways we can choose, that choose is important, 3 items from 8, what we have to do then is divide out that whatever number we're taking at a time. So we were doing 3 choices at a time, so that means that arrangement of 3 factorial has to come out of there because that is only one combination. So if I was choosing 4 things at a time, then that would mean I would have an extra set of combinations here. This would be double. There'd be 12 choices that we would, or 12 arrangements that we would have, but that would still only be one combination of items. So what we have to do then is divide out that repeat. So we're going to divide out the 3 factorial permutations because they're repeating. It doesn't matter that I can take those 3 things in 3 different ways. because it's all going to give me the same meal, or in this case, the same set of judges when I'm done. So we're going to divide out the 3 factorial permutations that are counted for each selection. I wrote that kind of big. So what that means then is that I've got 8 factorial. If I take out the 3 factorial ways that they're going to be arranged, then what that leaves me with is 5 factorial. And when you calculate that, it equals, whoops, nope, 8 factorial leaves me with 336. I did this a little bit wonky, and then I'm left with 3 factorial ways to arrange those. So that leaves me with 56 ways of choosing Okay, let's try another one. So it says, suppose the local TV show needs to choose 3 people from 8 candidates to judge this singing show. However, the first person selected serves as a head judge, the second person selected is a major judge, and the third person selected is a minor judge. So how many ways can we choose these? So because the first one is getting a particular spot, the second one's getting a particular spot, and the third one is getting another spot, then this one means that order matters. Okay, because we have a first spot, a second spot, and a third spot that are going to be filled for particular things. So for this one, order is going to matter for first, second, and third. So if I take a look at this, for my head judge, oops, I should put a blank on top of there. For my head judge, I can choose from all 8 of those people. That means that what I'm left with for my second judge, or the major judge, I guess I could put major, if I've taken that person out of it, then I've only got 7 choices left. For the minor judge, I've taken 2 of them out of there, so then that means that I'm left with 6 selections, or 6 that I can choose from for my minor judge. So that is equal to 336, which is the same thing, because it's an arrangement, as saying 8 permute 3. So that's like 8 factorial over 8 minus 3 factorial, which is 336. Okay, so the next one says, suppose a local TV network needs to choose 3 people from the 8 candidates to judge the amateur singing show, and how many ways can they be chosen? So there's no restriction on here. It doesn't say we have to have them arranged in a certain way. So what I'm doing then is I've got 8 possible ways of arranging or choosing my combination of judges. Because I'm taking them 3 at a time, and it doesn't matter the arrangement of the 3 of a time, that means that I'm going to have 3 factorial that I have to divide out, because the arrangement of them doesn't matter, which leaves me with the other 5 judges that can be chosen in whatever order I want to. So that means that I have a 5 factorial. So this then, when you divide it out, is equal to 56. So it says in general, what we've done here is we have taken a combination of taking 8 objects and we're taking them 3 at a time. So this is a combination, if you were to read it, of taking 8 objects, and we're taking those objects, filling our spots 3 at a time. So in general, it says the number of combinations of n distinct objects taken r at a time is equal to n factorial, so the total number of ways we can take them, times our r factorial, and r factorial is that permutation of, okay, of how many am I taking at a time? And we're multiplying that to the ones that are left and how we can arrange them. So this is equal to the NCR formula, and you might have noticed that on your calculator. So you're taking your total number times the number that you are taking at a time, factorial, or divided by the number you're taking at a time, times what's left. What is the combination of arrangements that you have that's left? Okay, so this says simplified, 8p3. So 8p3, if we took 8 objects and rearranged them 3 at a time, we would have 8 times, and using our formula, this would be 8 minus 3 factorial. Okay? And 8 factorial divided by 5 factorial, I can't remember, I think that equaled 3, no, I want to say 336, but I could be wrong. I'm not going to simplify it here. If we did this as a combination, if we took 8 things and chose them 3 at a time, then what we're doing is we're taking our total number, we're taking, okay, how many are we arranging at a time or selecting at a time? 3, and that means that there's 3 factorial ways we can change them or arrange them, and multiplying that to the number that are left and the number of ways we can arrange them. So there's similarities between permutations and combinations. The thing with combinations is we don't care about that arrangement of those objects we're taking at a time, so we have to divide that out of your total number of choices. Okay, so if you have something like this where it says write an expression for the following without factorial notation. So that means that we're going to change it into our formula, and then we're going to do our expansion so that we can get rid of the factorial, just like we did with the permutation ones. So in this one, our n value is equal to n, and our r value is equal to 3. So my formula here is n factorial over r factorial times n minus r factorial. So to expand that, I'm going to expand my bottom first so you can see how far to go on the top. My r factorial was 3 factorial. My bottom then is n minus 3 factorial. So that means I need to take my top and expand it down to n minus 3 factorial so that I can get rid of my denominator and my factorials. So n factorial is the same as saying n times n minus 1 times n minus 2 times n minus 3, and I could continue. But because now it matches the bottom, I just drop in my factorial there. So my n minus 3 factorial and n minus 3 factorial cancel. So what I'm left with here is n times n minus 1 times n minus 2 all over, and then 3 factorial is just 6. So the next example says simplify 13 choose 7, or 13 seek 7. So that means my total number is 13 factorial. My repeat, my r value is 7 factorial. And then inside, I'm left with 13 minus 7 factorial that I still need to take into account and arrange for. So this is 13 factorial over 7 factorial times 6 factorial. So what you'll notice is whatever you have on the bottom will add up to give you what you have on the top. So this in your calculator would be 1716. So same thing in your calculators. You do your math, go to PRB, and then choose the NCR button, which is number 3 on the TI-83s. So the next one says write an expression without factorial notation for NC2. So same thing as we did in the last example. On the top, I would have n factorial over 2 factorial times n minus r, so n minus 2 factorial. So that means my top I need to expand till I get to n minus 2 factorial. On the bottom, 2 factorial times n minus 2 factorial. Those will cancel, so my expansion would be n times n minus 1 over 2. So it says, in previous lessons you've learned that a permutation is a selection from a set of objects which order is important. So how you arrange them matters. Now you've learned that a combination is a set of objects in which order is not important. And it is important that you keep that distinction in mind. If you're arranging something, they have to be in a specific order. If you're just choosing something, so think of the Manchu walk, they don't care what order you tell them to put the things on your plate. You're still going to get a number 3 combination or a number 4 combination if you're choosing 4 things. So it says try to determine if the following examples of combinations or permutations and find out how many combinations and permutations are given of the given problem there are. Answer in factorial notation, then evaluate. So what's that saying is we're going to expand it, and then we're going to solve it. So it says determine the number of ways an executive committee of 3 students can be chosen from 10 students council members. So when I take a look at that, it's given me a clue by saying chosen. Chosen is a good clue that that's going to be a combination. Doesn't matter who gets first, second, or third place in this executive. The question doesn't say that, so that means this is a combination. They don't care in what order we pick these in, they just want us to pick 3. So this one would then be a combination. So that means I would be doing 10 objects chosen 3 at a time. So this would be 10 factorial over 3 factorial times 10 minus 3 factorial, so 7 factorial, which is 120. So this was our clue here for chosen, and the fact that it didn't say first person chosen has to be this, second person has to be this, third person has to be the next position. So it says determine the number of ways an executive committee consisting of a prime minister, deputy prime minister, treasurer, and secretary can be chosen from 10 student council members. So this one, because we're putting them in specific spots, the arrangement is going to matter. The first person chosen is prime minister, second is deputy, third is treasurer, fourth is secretary. Or it could be the combination, or the arrangement of that could be reversed. But regardless, they have to go in a specific spot. So because that arrangement is important, then we need to do a permutation. Okay? So the order for this matters. Because once you're chosen, let's say you're chosen to be the deputy prime minister, then you can't be chosen as prime minister or treasurer. Somebody else has to be chosen for that spot. So once you're chosen, that should be once, chosen for one position, can't be in another. So that makes this a permutation. We're going to arrange these people. So it's a 10 P, is it 3 or 4? 1, 2, 3, 4. So permutation is 10 factorial over 10 minus 4 factorial. We're taking out that combination or the order of how we're going to arrange those 4 people. So this is 10 factorial over 6 factorial, which equals 5,040. Okay, a basketball team consists of 7 guards and 5 forwards. The coach starts 5 players and has decided to start 3 guards and 2 forwards. In how many ways can the coach select the starting 5 players? Okay. So for his players, he's got his guards. And so he's got guard 1, 2, 3, 4, 5, 6, 7. For his forwards, he's got 5. So he's got player 1, 2, 3, 4, and 5. So he's choosing 3 guards and 2 forwards as his starting lineup, let's say. So let's say he chose person 1, 2, 3. Doesn't matter if he chose person 1, 2, 3 or person 3, 2, 1. So then that means that these other 4 guys are going to be on the bench for the beginning. So because it doesn't matter what order he's choosing his 3 positions in, then that means that he is out of those 7 possible people, he's choosing 3. So this is a 7 choose 3 combination. So from his forwards then, let's say he selects the first 2 because he's choosing 2 forwards, then these other 3 he's not. So that means that out of his 5 possible forwards, he's choosing them 2 at a time. So 7 choose 3, if you put that in your calculator, that's going to give you 35 possible combinations of guards. From his forwards, that 5 choose 2 leaves him with 10. So that means he's got 35 ways of choosing guards, 10 ways of choosing forwards, so in total, when he multiplies those 2 together, that's going to give him all of his possible combinations of choosing. So 35 times 10 is, so he's got 350 possible starting lineups. Okay, so there's our formula at the top. It says you can compute, and I've kind of told you this already, NCR or NCHOOSE are directly with your calculator. So just in case you haven't tried it, for this one then, in your calculator you would do 52, math button, do the left arrow key so that it puts you on PRB. Then we're selecting number 3 because that's the N choose R combination. And then because the number of objects we're taking at a time is 5, so you put your 5 and your enter. And when you put that in there, you should get 25,989. Oh, did I say that wrong? No, it should be 2,598,960 choices. Okay, the next one says, the Canadian Chess Association has 13 members on its voting council. A 4-member subcommittee is to be selected to organize tournaments. How many different subcommittees are possible? So does it matter how we're arranging these? It's not saying, give me the arrangement of how I can put these 4 people on the subcommittee. It's just saying I want to choose 4 people out of these 13. So using my NCR, because it's a choose, the arrangement I pick them in doesn't matter. It is 13 choose 4. So that's 13 factorial over 4 factorial times 9 factorial, which is 715. And again, you could do it this way on your calculator using the factorials, but that's a lot more buttons to push when you have to do that math, or right arrow, and then select factorial, and then do the multiply. So I would just do straight into your NCR one there. So it says how many 4-member subcommittees are possible if the voting council president, vice president must be members. Okay, so for president then, one person is going to be chosen from, and this is the subcommittee, so there's only 4 people on this committee, right? So there's 4 people on this committee, so one of them is going to be chosen at a time for vice president. Your VP is one person chosen one at a time. And then that means from your other members that you have, and there's 13 in total, 11 are left, and you're going to choose 2 from those 11. So this is the rest of the committee. Okay, so the council president and the vice president are already members of this committee, so then that means you've only got one person who is the vice president and one person who is the president, so that's just a 1C1. Or if you do that on your calculator, you're going to find out that that just equals 1. So that selection is already taken. The vice president is also taken by that same thing. It's been picked and has to be on that committee. So that means that only leaves you 11 people to choose for the rest, or to choose from for the rest of your committee, and we only need 2 of those. So this is 1 times 1 times 11C2 is 55. So we can make 55 different subcommittees. Okay, combinations are, we use a lot of that when we're playing cards. Things you need to remember when you're playing cards are just based on this chart here. There are 13 in each suit. There are 26 in each color, and 52 total. Okay, we don't count the jokers when we're doing these questions because they don't belong into either clubs, spades, diamonds, or hearts. If it says 54, then you know that that's what your deck is including. So you have 13 of each suit, 26 of each color, 52 total. Okay, so the first one says how many different 5-card hands are possible? So I've got 52 choices of cards. There is no stipulation on there that they can't all be clubs or spades or a combination of the 4. So that means I have 52 cards to choose from, and I'm choosing them 5 at a time. So this means I could have 2,598,000, did I miss a number? No, 598,960 possible 5-card hands. So it says how many different 5-card hands are possible that consists of all diamonds. So I'm narrowing it down. I'm saying I can only use diamonds. So from my 5 cards, I'm only taking the diamonds. I've basically thrown the other 3 suits out. So that means I've only got 13 cards to choose 5 at a time. So then that lowers the number of combinations I can have of hands to 1,287. So now the next question, it's even restricting you a little bit more. It's saying you're getting five cards total, but 2 of them have to be spades and 3 of them have to be clubs. So that means, again, I'm narrowing it down. I've only got, for spades, I've got 13 to choose from there, and I'm taking those 2 at a time. And then I'm going to include that with my 13 clubs that I get to choose from 3 at a time. So this equals 22,308 possible hands that I can make with 2 spades and 3 clubs. So what if I'm still doing my 5-card hand, but I want to have 3 kings in there? So if I look at my kings on the chart on the other page, there's only 4 kings, 1 of each suit. And I'm choosing those 3 at a time. So the rest of my cards are coming from what's left. So that means I've got 48 cards to choose from. And I want 5 cards in total, so that means I have 2 cards left to choose from. So that means I have 4,512 possible hands with that quality or qualifications. How many different 5-card hands are possible that consist of 1 queen and 3 jacks? So I've got 4 queens, I'm choosing 1 of those. I've got 4 jacks in my hand, and I'm choosing 3 of those. Now I need to make up a 5-card hand, so I've used 1 and 3, so I've used 4 of my spots already. So that means out of the other 48 spots, I'm choosing 1. So my total number for the last part is always what's left. So that means I have 704 when you multiply these all together. I'm trying to read my writing. All the face cards are removed from the deck of cards. 3 cards are dealt from the face cards. How many 3-card hands are possible that consist of 1 queen? So for face cards, I'm just going to flip back here. Those are just the king, queens, and jacks. So that's just this area here. And I only have 12 possibles from there. Okay? So if I take out my 12 face cards, that leaves me with 12 cards in total that I'm going to choose from. So it's saying how many 3-card hands are possible that are going to consist of 1 queen. So that means I have 4 possible queens that I can choose from here, and I want to choose 1 of them. That means that what I'm left with for the rest of my hand, and this is 3 cards. So from my 12 cards, I'm using those 4 queens for my first spot to choose from the first spot. So that means that I've got 8 cards left to choose from for my last 2 spots. So my 4 and my 8 give me my 12, and my 1 and my 2 give me my 3. So when you multiply these, there are 112 possible hands that you can get. Okay, so City Council has decided to form a subcommittee of 6 council members to organize special events for the next year. City Council has 15 members, so that's the total. Subcommittee has 6. 9 are female and 6 are male. So we've got 9 female and 6 male. So it says, how many committees can you make if you have to have at least 4 females? So these you have to be careful with. The other one said 1 queen, 2 spades, whatever. This one has at least. So at least means that I could have 4 females, I could have 5 females, or the maximum number I could have is 6 females. So because I have 9 females in total, then that means I have 9 choices with only 4 of them being female. So that means what I'm left with is, for my committee there, there are 6 other people left from the total of 15, and that means that if it's a committee of 6, only 2 of them will be male. So this is 9, choose 4, and then my male is 6, choose 2. I have an or though. An or is different than and meant that I multiply all these together. If it's an or, that means I'm going to add all of my committees together. Okay? So if I had 9 females and I'm choosing them, I want 4. 4 is the least number I can have on there. So what about if I did, from my 9, I chose 5 females? Then that means that the rest of the committee, from the 6 men, I'm only going to be able to choose 1. For the last committee then, that's my 6 females. So I'm going to choose my 6 females, and I'm going to choose, sorry, not my 6 females, my 9 females. And I'm going to be choosing, I put an F there, my 9 females that I'm choosing 6 at a time. So that means from my males, there's 5 of them, but I'm choosing none. Is there 5 males? Sorry, there's 6 males. Okay. So my first numbers when I take a look at them, my 9 and 6 give me my 15. That's always my total number that I'm starting with. And my following numbers, or the R numbers, the 4 and the 2, have to give you what you're trying to combine. So when I do this, I have 1,890 plus 756 plus 84. So I've got 1,890 possible combinations of having 4 women on there. I have 756 possible combinations of having 5, and 84 possible combinations of choosing those all 6 women. So when I add this, I have 2,730 possible ways of choosing a subcommittee with those restrictions on it. Okay, if I have to have at least 1 female, so then that means that I'm going to have 1 female, or 2 female, or 3, or 4, or 5, or 6. So at least means that I'm going to have 1, 2, 3, 4, 5, or 6 people on that committee. So my total possible amount that I could have on there is, if I chose, is to have 15 choose 6. So my total possible number of committees is to take, from my 15 people, I choose 6 of them. So if I take all of those committees and I just subtract the number of subcommittees with no females on there, because what that's doing is it's taking out the 1, the 2, the 3, the 4, or the 5, or the 6 possible subcommittees. So if I subtract, what are the chances then of getting number of committees with no women on there? Because I can go from 1 to all. Then what if I take away, the simpler way is to say, what if I just take away the number of subcommittees with no females on there? So that means they would be all men. So you can do that when it's an at least 1 situation. Find all your possible ones, take away combination of not having any of them on there. So this would be How many males do I have? I have 6 males, and I'm going to choose a committee with all males, so I'm choosing them 6 at a time. So this is equal to 5,005 minus 1, which is just equal to 5,004. So there's 5,004 possible combinations of having 1, 2, 3, 4, or 5, or 6 women on a committee. At most, 2 females. So at most means then you could have 0 females, or you could have 1 female, or you could have 2 females. So if I do that as a combination for the 0, I'd be taking my 9 women, choosing them 0 at a time, which means that my men, I'm choosing all 6. Or I'm going to take my 9 women, I'm going to choose 1 of them at a time, which means that my men, I'm going to choose 5 of them. And if I'm going to take 9 women and choose 2 of them, that means that from my 6 men, I'm going to choose 4. So this is equal to 1 plus 54 plus 540. So that is equal to 595 possible combinations with having at most 2 women on there. Okay, last example, back to the cards. Consider a deck of 52 cards. How many different ways, different 5-card hands are possible that consist of at least 3 clubs? So at least 3 clubs means that you're going to have 3 clubs or 4 or 5 clubs. So you have to think, how many clubs do you have in a deck of cards? There's 13 clubs. So I'm going to choose 3 of those. So then that means that out of the other cards that are left, so 52 minus my 13 leaves me with 39 other possible cards to choose from. So 39, and that means that I need to have 5 cards in total, so choose 2. Or I'm going to take from my 13 clubs, I'm going to choose 4 of them, which means then I am left from the other 39 cards, I'm going to choose 1. Or I'm going to take from my 13 clubs all 5 cards, which means from the rest of the cards, I'm just going to take none. So you put that in your calculator and you have 241,098 possible 5-card hands you could have where you have at least 3 clubs. Okay, so how many different 5-card hands are possible that consist of at least 1 red? So right there, as soon as you see that at least 1, then you take a look at, okay, so what happens if I have no red cards? What are my possible combinations of getting no red cards? So that means that you're going to take your total number of 5-card hands, and you're going to subtract your combination of, oops, I don't need the of in there, of having no red cards. Oh, no red cards, which would mean they'd be all black. So total number of 5-card hands, I have 52 possible cards in my hand, and I'm going to choose 5 of them. Minus, how many black cards do I have in my hand? 26 are black, and I'm going to choose 5 of them. I'm going to make all 5 of my cards black. So that is equal to 2,598,960 possible 5-card hands I could have, minus the number that are going to be all black, or in this case, at least 1 red, or sorry, no, that are no reds. That leaves me with 65,780, which is 2,533,180. So at least if it says at least 1, not at least 2, that won't work. But if it says at least 1, then you always take your total number minus the combinations that wouldn't have any. How many different 5-card hands are possible that consist of at most 2 jacks? At most means I can have 0 jacks, or 1 jack, or 2 jacks. So as soon as I'm doing an or, I'm going to add in my combinations. If it's an and, then I'm going to multiply my combinations. So I'm looking at a 5-card hand. How many jacks do I have in a hand? I've got 4 jacks, and I'm going to choose none of them. Then that means from my 48 cards that are left, I'm going to choose 5. If I have from my 4 jacks, I chose 1, then from the other 48 cards, I'm going to choose 4. And, or I guess not and, or I can have from my 4 possible jacks, I'm going to choose 2 of them. Then that means I'm going to have from the other 48, I have to choose 3. So when you calculate this, it equals 2,594,400 possible hands that will have at least or at most 2 jacks. Okay, so sometimes you're going to be given an NCR formula and they're going to ask you to find one of the variables. It's going to actually give you what does the combination equal. So what is the number I've started with, or what is the number that I'm taking at a certain time or that I'm choosing. So NC2, so we can use this with that factorial notation. So NC2 means that I have 15 is equal to n factorial over r is 2 factorial times n minus 2 factorial. So that means I have to do my expansion. 15 is equal to n times n minus 1 times n minus 2. I stop when I'm identical to the denominator. 2 factorial times n minus 2 factorial. So this and this cancel. I'm just going to continue it up here. So this leaves me with 15 is equal to n times n minus 1 all over 2 factorial is just 2. So if I cross multiply, I have 30 is equal to n squared minus n, so I've just distributed that. So to solve for this, I need to bring everything over to one side and factor. So n squared minus n minus 30, that leaves me with product and sum of n minus 6 times n plus 5. So my n is going to be 6, or n is going to equal negative 5. Well, right away I know I can't do a negative value, so n is equal to 6 is my final solution. Solve algebraically using factorial notation. NC2 is equal to 55. So that means I have 55 is equal to n factorial over 2 factorial, my r is a 2, times n minus 2 factorial. So same idea as the last one. This is 55 is equal to n times n minus 1 times n minus 2 factorial all over 2 factorial is just 2 times n minus 2 factorial. Those will cancel. 2 times 55 is 110. I'll go up here. 110 is equal to n times n minus 1 is n squared minus n. So 0 is equal to n squared minus n minus 110. So product and sum is n minus 11 times n plus 10. So n is equal to 11, or n is equal to negative 10. Again, I throw out that negative, so n is equal to 11 is my solution. And I'm just going to check, but I think that was the last example for this. So the biggest thing with combinations is to remember that your arrangement doesn't matter. But we need to keep that in mind when we're doing that, because that arrangement doesn't matter. When you can arrange, if you're picking 3 things, you can pick them in 3 different orders. So we have to get rid of that factorial that is repeating. So that's why we do that divide out.